Hello and welcome back to my channel, and today I'm gonna be looking at DCS or Digital Combat Series, which I do believe is commonly known as a Digital Combat Simulator. Now this game is something that I wanted to actually try out a long time before, but there are quite a few issues for me to actually do it. First and foremost, as much as I want to do this game in 4K, I can't do it, not because the GPU is too weak, but because I literally cannot see anything on a screen. So yeah, let me just show you guys what I mean. Basically, this is how it looks in 4K. Yeah. I think I just needed to show you guys in comparison what I'm talking about when I say I cannot see anything. Back to Full HD. So now we're back in Full HD, and the second issue I'm having is this game is kinda meant to be played with a joystick or an actual HOTAS setup with a joystick, rudder pedals, and throttle control, and well, basically all the bells and whistles, which I also do not have, so I'm stuck with keyboard and mouse, and this game is the Tarkov of flight sims. You have shortcuts on the keyboard you never knew your fingers are supposed to reach, like up to 4 buttons at the same time or in a sequence, and that's only to adjust a flap or something. So honestly, I don't know how this is gonna end, but here we are. So let's take a look what we're gonna be flying here with. So we're going with everything high, Full HD, everything else is, well, as much as I can crank out. I'm not sure about SSA and SSLR. I'm gonna leave them as they are, and basically it's just high settings with something still maxed out, because for whatever reason once you select the high preset it goes to medium on some of these, specifically for shadows and stuff. Grass, forest, and everything else is maxed out as it is, and my plan of attack is to actually get familiar with an aircraft and show you guys how it actually looks and feels when you're going through the training. So I'm gonna start the training. And there are 2 aircrafts available. One of them is the Russian Su-25T, which is an actual fighter jet. Well, fighter jet is a strong word for it, but you can use it to fly fast and attack things. And another is a TF, which I do believe, considering that the training curriculum is very short, like cockpit familiarization, engine start procedure, and everything like that, is very short. I kind of think this is something like a Spitfire level, single prop. I'm not sure, but I think without further ado, let's go in, see what we end up with, see what Full HD is taxing out on our system, and if I can make head or tails out of this. So let's go. Oh, I think I was right. Look at this. This looks like a single prop. DCS is kind of good at showing you the aircraft you shall be flying with if you select it. So I think this is our victim, which is unlucky to have me by its steering things, but hey ho. So I wonder how hard this training is gonna be. Well, technically familiarization with the cockpit should be fairly straightforward. I'm not sure how deep in knowledge this sim goes, but seeing how people are playing this on YouTube, and I do believe this is probably #1 of combat sims par Microsoft Flight Simulator, I do believe this is gonna be pretty in-depth. So what do we have here? We have a start side USA, my task nothing. That's a perfect mission data. I like it already. Allies flight is a Yak and a UH-1H. Yak is, again, it's a Russian plane, I do believe. Known threats, not applicable. Great stuff. Temperature plus 18 degrees, even warmer than I'm currently am, so that's great to see. Right, anyway, let's fly, see what we have.
Welcome to the Cockpit Overview lesson. Today, we will take a detailed look at the Mustang cockpit. You can use mouse look mode to move your view around the cockpit. To turn mouse look mode on and off, press left Alt plus C. Throughout this lesson, pressing the spacebar key will initiate the next consecutive step once instructions for the current one are complete. Press the spacebar key when you are ready to begin.
Okay, so left Alt and C, there we go, the first thing. Oh, We have acquired looking around. Perfect. I'm like an owl. I can look behind me. I do not have a body, so probably I'm a ghost. Right, so we have flaps down on the wings. Let's see if I can... oh, we can zoom in. Let's see if I can make head or tails of this instrument panel around here. I do have very little knowledge about aircrafts. Definitely not a fighter one. So let's see what we can actually get here. So... the big dial looks like degrees west-east. That's the compass. That looks like the clock. That looks like a cheat sheet for takeoff. Flaps, streams, radiators, mixture, propeller, friction lock. That doesn't look like a takeoff to me. Okay, what is this? Suction. Suction? Is it going to show how much we suck at this? I mean... It probably has to do something with a vacuum, but what kind of vacuum would be in a plane? I mean, it must be some combat stuff related. Manifold pressure, pretty self-explanatory stuff. If you remember first Fast and Furious movie, manifold pressure was the problem of everything. Let's go over here. This looks like our airspeed, and we are limited at 500 miles per hour. Great stuff. That looks like our heading. That's the roll, perfect. Coolant temperature, same in the car. Carburetor temperature, I guess that's engine temperature altogether. RPM, so that's the engine RPMs we have. Great stuff. What is this? Altitude. Well, altimeter is quite standard. Wait, I thought this is our pitch and yaw. What is this? Probably the roll, because this looks like a old school with the air bubble, so we don't really have a gyro. They should have a gyro. That should be a gyro. Anyway, we'll see. We have the climb rate. Fair enough. We have... oh, we have a G meter. Or just to show how much G's we're taking, which is accelerometer. So, you know, usually it's plus G's blackout, minus G red out. If you played any of the combat sims before. This is... temperature. So this is engine temperature, I believe. There's a fuel temperature and oil temperature, or that's pressure. I would say that is pressure. Fuel cannot have a temperature. Well, technically it can, but not really. What else we have here? This is the throttle. Fair enough. Radiator, coolant, air controls, oil, landing lights off on automatic. Okay, interesting. Aileron Control. Okay, what is this? Trim. God, the details on Full HD is actually pretty decent, to be honest. We're sitting way above 60 frames. What else we have here? IFF detonation circuit? IFF? Is that like a friend or foe? I'm not sure. That looks like the radio, phones, communication, okay. Signal light, power switch, test switch. What is this? Wing, bright tail. Oh, so that's the lights. Okay, fair enough. What is this? This looks like for closing the canopy. Something red, should not touch probably. Emergency pull, so that's gonna eject the canopy, fair enough. What is this? This looks like a pump of some sort. Is that for hydraulics? I'm not sure. So we have oxygen cylinder pressure, so that's for our internal tank. Since this will be climbing high, we probably need a separate oxygen for the pilot. Oxygen flow indicator. I guess it's working. I'm not sure why it's like opening and closing like this. That's a first for me. Ignition, left, right, off. Rocket safe. Okay, fair enough. Cockpit lights on, off. Good. What is this? Hydraulic pressure. So hydraulic pressure is a big thing in these planes. Literally everything works on hydraulics. You might have seen in the movies when they say I've lost hydraulics. That means that if you've been hit and hydraulics are leaking out, you have nothing to actually control your plane with. Your ailerons, your rudder, all of that is using hydraulic fluid to operate. Also landing gear. If you do not have a landing gear, you basically cannot really land. Well, you can on a belly, but you know, you better keep that hydraulic pressure up. That red thing probably is emergency for hydraulics. You can kind of manually open up the hydraulic bay and put out the landing gear. At least I think so. I'm not sure. So this is fuel on, shut off. Okay, so that's for fuel cut off. Fair enough. Drop for the tanks. Right hand, main tank, fuel. Okay, so I guess that's switching between tanks. What is this? Fuel booster, oil dilute, starter, primer. Okay, so since we have a carb or carbureted engine, so we would need to use the primer to prime the oil and fuel pressure, then we need to start it. Fair enough. I'm not sure what the fuel booster or oil dilute does in this aircraft. Actually, well, since this is not a car, I have no idea what it does, full stop. Landing gear warning lights push to something, so safe, unsafe. Probably when there's a landing gear failure, it's gonna light up one or two or both, or none, depends where we're hit. And it kinda looks pretty decent. I'm not sure what that is. Also, it's not really made very good. The only thing I'm missing is the flaps. Where the hell is my flap control? I can't take off or land the plane without flaps. Huh. Does look good. Right, anyway, let's go through the actual training, see if I manage to nail at least some of these things. I want to know what the suction is for. And I want to know where my flap's at. Also, what the hell is this supposed to be? I mean, if that's not a gyro, I don't know what that is. That's definitely a roll indicator, but what is that thing? Anyway, let's go and press space and see where we're at.
The cockpit is configured in a standard layout, with the instrument panel positioned on the front dash, a center-mounted control stick, a throttle quadrant on the left side, and various aircraft system controls on the left and right panels. With the exception of the flaps control handle, which is located in the bottom left corner of the cockpit, most of the indicators and controls are well organized and easy to read and reach. Moving on to the instrument panel, the upper left corner houses the remote indicating compass. The compass unit is installed inside the left wing and transmits magnetic readings electrically to the cockpit indicator. Using a remote compass avoids the magnetic effects caused by armor plating around the cockpit, experienced by a standard magnetic compass. The remote indicating compass includes a heading needle, which shows the current heading, and a desired heading needle, which can be turned using the indicator knob to set a desired course reference on the indicator. To turn the knob, you can simply roll the mouse wheel over it. To the right of the remote indicating compass is a standard clock. The winding knob can be used to set the time. Doing so requires pulling the knob out with the left mouse button, then rolling the mouse wheel over the knob to rotate it.
Come on, move over to the suction part.
The suction gauge indicates the amount of pressure in inches of mercury being generated by the engine vacuum pump. Vacuum pressure is used by a number of vital instruments, including the flight indicator, bank and turn indicator, and the directional gyro. A suction reading above or below normal means the readings of these indicators are unreliable.
So directional gyro should
Next
be this
is the
one.
manifold pressure indicator. This is one of the primary instruments used in flight, and together with the tachometer or engine RPM indicator is your main reference of engine power. The manifold pressure indicator shows gas pressure inside the engine induction system prior to entering the cylinders. Like the suction gauge, the indication is in inches of mercury. Manifold pressure is set using the throttle handle, while engine RPM is set using the propeller control lever, also on the throttle quadrant.
Okay, right, let's go for the coolant temp.
On the left side of the middle row of the instrument panel is the airspeed indicator, which shows an indicated airspeed in miles per hour, mph. The red line on the indicator marks the maximum permissible airspeed of 505 miles per hour. It's important to remember that maximum permissible indicated airspeed is reduced as altitude increases. For example, it is 400 mph at 20,000 feet and 300 mph at 30,000 feet.
So you can't use the full speedometer. Great.
In the left center of the instrument panel is the directional gyro, which shows current heading. The instrument can be caged and the heading adjusted manually by pushing in and rotating the indicator knob.
Oh, so the heading usually would be at the top. Ah, that's interesting that it's on the panel. Okay. Like, never mind. Let's go.
In the center right of the instrument panel is the flight indicator, which shows the aircraft's roll and pitch attitude relative to the horizon. The indicator is limited to 60 degrees in pitch and 100 degrees in roll. The instrument can be caged or uncaged using the caging knob in the lower right corner of the indicator. The horizon level can be adjusted vertically using the pitch adjust knob.
What the hell is that if that's the pitch and roll? Is that how you drop bombs? What? This is so interesting.
To the right of the flight indicator are two temperature gauges, the coolant temperature gauge above and the carburetor air temperature below. It's important to monitor these instruments in flight, as temperatures rising above normal may lead to serious engine problems, such as detonation and pre-ignition. On the right side of the middle row of the instrument panel is the tachometer. This instrument indicates engine speed in revolutions per minute, RPM. The pilot controls engine speed using the propeller control lever on the throttle quadrant. A propeller governor system automatically adjusts propeller pitch angles to maintain the RPM set by the pilot. Typical RPM settings in flight will be between 1,800 and 3,000 RPM. Moving to the bottom row of the instrument panel, the left corner houses the altimeter. The altimeter shows barometric or pressure altitude using a 3-needle system. The shortest needle shows altitude in tens of thousands of feet, the middle needle in thousands of feet, and the longest needle in hundreds of feet. The indicator knob is used to adjust the sea level reference pressure in inches of mercury to ensure an accurate altitude reading over a desired location where the sea level air pressure is known. Next is the bank and turn indicator, primarily used to maintain coordinated flight and minimize side slip. The vertical needle of the instrument indicates turn rate, and the slip ball indicates side slip or side skid. In flight, the pilot maintains the ball's center by using stick and rudder controls, or aileron and rudder trim. Flight trim is very sensitive to changes in engine power and airspeed, so constant attention must be paid to the bank and turn indicator in order to fly as efficiently as possible.
Ah, I see. So if we turn too harshly, we're gonna lose energy of the aircraft, basically, and then we're gonna lose speed. We lose lift. So that's the reference to the ground, that's the reference to the actual aircraft angle. Well, I wouldn't say close enough, I was completely off, but that now explains why there's two separate gauges. Okay. That's probably the climb rate. Please be the climb rate.
To the right is the rate of climb indicator, which
Yes.
shows the climb rate in thousands of feet per minute. Further to the right is the accelerometer, or G-meter. This indicator shows the G-load factor experienced by the aircraft, as well as two additional needles that show the maximum and minimum G-loads attained since the instrument was last reset. The instrument includes a reset button used to reset the needles to 0.
I was wondering why the G is not on 0, but obviously you need to do it. Also, I do believe that's the same as for altimeter. If you're taking off from a mountain, you need to set it up above sea level based on the altitude you're on. If you're gonna set it up on 0, if you're on the top of a mountain, it's gonna read wrong, and you're basically gonna crash. So that is an important thing. I'm not sure if this game actually has this thing. You obviously nowadays aircrafts, they use GPS to actually monitor your flight altitude, but you still need to set it on ground. But interesting. Gee, so that's for aircraft. I do believe that also applies for the human inside the aircraft, not only the aircraft. Although that'd be kind of cool, but hey ho. So let's see if I nail this one.
Finally, on the very right is the engine gauge. This instrument includes 3 indicators: the oil temperature gauge, oil pressure gauge, and the fuel pressure gauge. Moving below the instrument panel, the engine control panel includes a number of important engine controls. These include supercharger blower switch, sets the supercharger to low, high, or automatic blower modes. Normally this should be set to auto. The jewel light indicator lights up when the supercharger kicks into high blower mode. Fuel booster switch turns the fuel booster pumps on and off. Oil dilute switch, used to dilute the oil with gasoline, which may be necessary when starting in cold temperatures. Starter switch, used to turn the engine prior to ignition during startup. Primer switch, used to feed fuel to the engine through the fuel primer system during startup.
So that's what the oil dilute is for. I was thinking like you dilute the oil with gasoline, like the aircraft fuel. Hey, people who fly fighter planes, is that like a normal practice nowadays? I don't think you guys dilute engine oil with fuel, do you? I mean, what about the lubrication and viscosity of it? I mean, that can't be healthy. I'm not an engineer who makes airplanes, but they're just so counterintuitive when it comes to cars. And obviously I'm gonna compare this to a car, even though it's an aircraft. You know, engine's an engine, but just the way it's been engineered to work for extended periods of time with very heavy loads, that I would say car engines, probably F1, would come close to it, is so insane. What is that noise? Someone just finished their training, unlike me. Great, let's move on.
To the right are the two landing gear warning lights. These indicate safe or unsafe states of the landing gear. For example, the unsafe red light will be on if the gear doors are open but the landing gear is unlocked. Adjacent to the landing gear warning light is the parking brake handle. Setting the parking brake requires the following steps. Pull out and hold the parking brake handle. Fully depress and release the brakes. Release the parking brake handle. Releasing the parking brake only requires a press of the brake pedals. On the right side below the instrument panel are the oxygen indicators, the oxygen flow indicator, and the oxygen pressure gauge. The oxygen flow indicator features a blinker that opens and closes as the pilot inhales and exhales on-demand oxygen. The oxygen pressure gauge shows the amount of oxygen remaining in the O2 tanks in pounds per square inch, PSI. A normal reading is 400 PSI.
Okay, that's all nice and cool, but the one thing I just noticed, there's no fuel level gauge, and in all the movies there's usually like a very big gauge that shows remaining fuel in both tanks or external tank, and I do not see that here. Like, I wonder what do it even have it, or you just have flight time in minutes? That way you just need to adjust the clock. That's gonna be a cool one.
Just below the instrument panel is the front switch panel, which includes a variety of important controls. Ignition selector switch selects the left, right, or both magnetos to operate the engine ignition system. Cockpit light switch turns on and adjusts the cockpit floodlights. Horn silence button silences the AN/APS-13 rear warning radar alarm. Below the front switch panel is the fuel control panel. This includes the fuel shutoff valve, used to open and close the fuel flow, and the fuel selector valve, used to select the fuel tank used to feed the engine. Correct fuel tank selection is important in flight to maintain a balanced aircraft. To the right of the fuel control panel are the hydraulic pressure gauge and the landing gear fairing doors emergency release handle. The landing gear fairing doors emergency release handle can be used to release the hydraulic pressure and mechanical locks holding the gear doors closed. This will open the fairing doors and allow the landing gear to fall down under its own weight. Slight rolling of the aircraft from side to side can be used to ensure the gear locks in place prior to landing. Normal pressure for the hydraulic system is 800 to 1100 psi.
Fantastic. So if you don't know if your gear's down, you just rock the plane. How did people fly this thing back in a day? God. Wow, this is like a death trap that shoots bullets. Wow, those guys are actual legends. Like, imagine knowing all this day in, day out, coming out and coming back in one piece. I wonder where the check engine light is, if they have one.
The surface control lock is used to lock the control stick in place when the aircraft is parked. Left-clicking over the pin locks the stick in a forward position, which leaves the tail wheel unlocked and allows the aircraft to be towed and turned easily. Right-clicking on the pin locks the stick in the neutral position, which leaves the tail wheel limited to 6 degrees of turn. Moving to the left side of the cockpit, the throttle quadrant dominates the forward section. The throttle quadrant includes the throttle handle, the propeller control lever, and the mixture control lever. In addition, 2 friction locks are mounted on the assembly and can be used to stop the movement of the throttle handle or the mixture and propeller control levers. The throttle handle features a microphone switch button used to activate transmission over the VHF radio.
So this is for the mixture. Okay, fair enough. So for those who's wondering why mixture is important, as you know, closer to the ground you have more oxygen. The higher you climb or the more altitude you take on, the more scarce oxygen there is. So there's less oxygen in higher altitudes. Considering we do have the supercharger here, it kind of will give or take act like a turbo. It's gonna compress all the air there is, but if there's not enough air, you need to adjust the fuel to air ratio that creates the mixture. Now in modern planes, this is kind of done by the ECU. It's gonna monitor the with a MAF or mass airflow sensor. It's gonna monitor the air coming into the engine. It's gonna adjust it automatically for these guys, same as with the airspeed and the maximum RPMs. Basically, you need to monitor how high you are and adjust it manually. There's no automatic setting for it, at least not yet. So this kind of makes sense. Obviously, since the mixture control is by the throttle, you can do it literally on the fly. So this makes sense, but it does require a little bit of brain to actually make this all work. So that's a lot of information to take in, but this is quite interesting actually. Let's roll on.
Moving back from the throttle quadrant, the radiator air control panel includes switches to operate the coolant and oil radiator flap doors. These are usually kept in automatic, but can be opened and closed manually when necessary. This panel also includes the landing light switch and the left-hand fluorescent light rheostat switch, which controls instrument backlighting on the left side of the cockpit. 3 trim wheels are used to set the aileron, rudder, and elevator trim. Take off with 5 to 6 degrees of right rudder trim to help compensate for engine torque. Trim settings in flight may vary depending on flight conditions. The 2 handles toward the left rear of the cockpit control airflow to the engine induction system. The ram air control handle controls whether air is ingested through the main intake under the nose or filtered intakes on either side of the nose. Filtered air is used when icing of the intake develops. The hot air control handle opens a vent door in the engine compartment to allow warm air to enter the carburetor. This can be done below 12,000 feet when icing of the carburetor is a danger.
Wow. This is so mechanical. Okay. I'm not sure I'm gonna remember the 12,000 feet warning for it, but guess we'll find out.
Probably the most awkward control in the cockpit is the flaps control handle in the bottom left corner. The flaps can be set from 0 to 47 marked 50 degrees in 10-degree increments.
So that's where the flaps are. Okay, if flaps are so hidden, which is weird, I would kind of expect them to be next to the trim lever. Okay, is the fuel control behind me somewhere?
The landing gear control handle is also on the left side. The handle is pulled in and moved up or down to raise and lower the landing gear as desired. The gear should only be moved when it's locked in either the up or down position.
Oh, so that is tied into hydraulic pressure. Wow, that's a lot of things in one little cockpit.
Now moving on to the right side of the cockpit, we have 2 canopy controls. The canopy is rolled open and closed by turning the canopy hand crank. The red handle is the emergency canopy release. When pulled, this will unlock the canopy and it will fly off into the slipstream. The oxygen regulator is used to control oxygen flow to the pilot's mask. The oxygen diluter lever, marked with yellow stripes, is used to set normal diluted oxygen or 100% oxygen. The red emergency valve is a separate backup oxygen line and can be used to bypass the regulator. The recognition light's keying switch is used to flash the recognition lights installed on the underside of the right wingtip when they are set to key mode on the electrical panel. The lights turn on for as long as the keying switch is held down and off when it is released. The electrical control panel includes switches for battery and generator power, pitot tube, and external lighting. In addition, the right-hand fluorescent light rheostat switch controls the backlighting for instruments on the right side of the cockpit. The electrical control panel also includes an important indicator, the ammeter. This shows current output of the generator in amperes. Maximum permissible output is 100 amperes. The ammeter does not show battery current. Finally, the electrical control panel also includes a circuit breaker bump plate. This can be pressed in to reset all the circuit breakers in case one or more of them gets overloaded and pops out. Further back from the electrical control panel is the AN/APS 13 Rear Warning Radar, or RWR. This device sounds an alarm when an object is detected behind the aircraft to warn the pilot of a possible threat approaching from the rear. Next is the Scr522vhf Radio, used for communication with flight members and air traffic controllers. The radio features 5 channels, the frequencies for which are preset and cannot be changed in flight. You should consult your mission briefing prior to starting a flight to ensure your radio is set up to contact ATC towers in your vicinity. The remaining radio systems, including the homing adapter, IFF transponder, and Detroller range receiver, are not functional in this aircraft.
So that's quite interesting. So obviously, since this is a quite old airplane, there is a little bit different procedure, I guess. So when it comes to contacting ATC, so apparently we're only using the one channel, which is the depart, and then probably we can switch over to communicate for the short range within Ally aircrafts for commercial flights, or if you're actually flying nowadays, you'll have to contact ATC, and then you'll need to contact ground control or departures to actually acquire information about your taxi, your gates, and everything else. ATC will point you to the direction of land here, go to gate, and then you need to contact ground. Also, that's gonna include the departures. If you're taking off, ATC is basically gonna tell you is it clear to take off or not, but departures will actually give you the slot and everything else. So that is that's good. We don't have to talk with too many people around here. Looks like that guy already finished his training. Imagine you get this training like before going into combat, and you go like, yeah, sure, I definitely will remember everything in the first try. I mean, also, the warning system about someone being behind us, that's a newsflash for me. I didn't know these aircrafts actually had a thing like that. I thought that it was more like, someone's behind me and poof, you're gone, or you just see bullets whizzing past you. That's a pretty cool thing. Also, they call this a Mustang, which is, I was under impression that Mustang was a P-51 really when it comes to US, but I'm clearly wrong on this, so that's an interesting thing. So what is this then?
Let's now take a look at the fuel gauges. You may need to twist your head around the cockpit a little to see them. You can press left Alt plus C to enable mouse view mode, and then hold down the mouse wheel while moving the mouse to move your head around the cockpit. The gauges for the left and right main tanks are located on the floor to either side of the seat.
I'm holding down the mouse wheel and nothing is happening. I want to do that. I want to see the fuel. Wait, hold up. Nothing is happening. I mean, I can touch things, clearly. Yeah, the knob is turning. Good, but I cannot move it with the thing this guy told me to move my thing with. How do I move around the cockpit? I mean, oh, hello there. I can move my stick. Wow, this would be so cool with the joystick. Actually comes back to the position if you do a roll. It doesn't when you do this. Okay, anyway, let's continue on.
The area under the seat also houses cockpit environmental controls, including windshield defrosting and cockpit heating and cooling.
Yeah, nice, which I cannot get. Good.
This concludes the cockpit overview lesson. Next time, we'll learn how to start her up.
Well, there you guys have it. Now apparently we know everything about what we have in a cockpit, and we can learn how to start her up. So I don't know, if you find this interesting and you want to see me try and fail, let me know in the comments down below. If you don't want me to try and fail, also please do let me know so I don't try and fail. But that's a lot of things in one cockpit, and this is, I would say, rather old aircraft. It has nothing to do with today's single props that you would get. So also this is a combat aircraft, you know, also it's a two-seater for whatever reason, but yeah, that's all that's all I have for you guys today. Thanks for watching, and I don't know, let me know what you think. Over and out.